Okay, this was the reflect problem on page 84 the students were supposed to do. I think I gave this to them on Wednesday, then with our day off, everything got goofed up. So if you didn't do this, I'll take a second to do this and I'll be right back. Okay, so on this one, um, it doesn't matter what this is. If you have a proportional relationship, if you have a 1 here for your x, this is going to be the unit rate. So if you have a point that has a 1 as the x, this is going to be the unit rate. As long as it's proportional, which we determined that this was a proportional relationship, the one about the cubic feet of water passing over the dam. So as long as you have a 1 here in the x, the y value is going to be the unit rate. They used an r, where r is the unit rate, but that's the y value. So it's kind of hard to have you draw a graph on this because I haven't provided any graphs to you, but we will be graphing here pretty soon. So this additional example says every 10 seconds an escalator step rises 6 feet. Find the unit rate of this proportional relationship. Now, how do you know it's a proportional relationship? Just by looking at the graph. Okay, by looking at the graph, it goes through the origin, so it's definitely proportional. But they're telling you that it's proportional. So they're telling you that at 0 seconds, the step rises 0 feet. So they're telling you that in the problem itself when they tell you it's proportional. Again, here's the graph that they had wanted you to create, but without giving you graph paper, that's kind of tough to do. So let's see, what is the unit rate? So the unit rate's going to be at 1. So, they want per second. So let's figure this out. I'll give you a couple seconds. Just pause and then come on back. Okay, so if the escalator rises 6 feet every 10 seconds, we want to know how much it's going to be in 1 second. So if you simplify this, you're going to get 3/5, and that's going to be 3/5 feet per second. So that'll be the unit rate, feet per second. Okay, so try the your turn for Thomas, wherever this kid is, and they want you to graph this too. So this is going to be proportional. It does say proportional. You can start at 0, mark your point of 2 miles every 10 minutes, mark that point, and you can start here and go through that point. Okay, so here we are at the graph, and there's your 0, 0, there's your 10, 2, close, and then here's my line. You should be using a straight edge to make your line. It's kind of tough on this iPad, but there's the line. That's what your graph should look like, similar. It asks you to find the unit rate on this proportional relationship. His unit rate and the slope of a graph of the ride both equal 1/5 mile per minute. Okay, so you graphed it. You go up 1, right 5, up 1, right 5. That's 1/5, and of course you can use these numbers for that too. All right, so this is on page, I think I should know this, wait a minute, 85. This is on page 85. And of course they have most of this done for you, but it's a really good example to go through. So you're comparing some proportional relationships different ways. So one way to compare is you have an equation. Of course, this 2 and 75/100ths, this is your constant of proportionality, or your slope, or your unit rate, all the same thing. You also have a graph, and so with the graph, you should be able to find the slope, which is the same as the unit rate, which is the same as the constant of proportionality. So the equation y equals 2 and 75/100ths x represents the rate in barrels per hour that oil is pumped from well A. The graph represents the rate that oil is pumped from well B. Which well pumped oil at a faster rate? So you're comparing this equation for well A to this graph for well B. Now to compare them, you should know their rate, their unit rate. So using the equation, they want you to make a table. So in 1 hour, it's 2, this should be 2 and 7/7500. This graph is wrong. So this page is wrong. It's 2 and 7/500. I'm not sure if your book has the same thing or not. But my teacher book has 2 and 7/500. I know this is wrong. 2 is 5 and 5/10, 3 is 8 and 2500, and 4 is 11. So 4 times 275 gives you 11. 3 times 2 and 7/500 gives you 825, etc. So use the table to find the slope of the graph of well A. The slope is the same as the unit rate. So here's a difference in the first two. So the change in Y, change in X, 2 and 7/500. You can get that right from the equation though. They just had you do some extra work. Okay. Come on. Okay, I think I have to go on to the next page. All right, so step 2, we just talked about that, finding the well A. So you're using those change in Y, change in X, 275. We talked about how you can do that with just the equation. Step 3, use the graph to find the slope of the graph of well B. This should be use the graph to find the unit rate, not graph. So find another error in this thing. So the slope is going to be the unit rate, rise over run. So we can start here. We can rise up to 10 and run over 2, or that's 4. I can make this sucker bigger. Come on. There you are. Go bigger. So here we are at 0, rise up 10 and go over 2, 4, because we're counting by 2's here. So 10 over 4. Okay, go back down again. Ooh, come on. Now he's not going to cooperate with me. Oh, this pain. This is a pain. Okay, I'm just going to get rid of you. There. Okay, so we have it as 10 over 4, which is 2 and 5/10. Now we made this 2 and 5/10, we can compare apples to apples. That is, this is already a decimal, make this a decimal. So 2 and 7/500 barrels per hour, 2 and 5/10, or 2.5 barrels per hour. Compare the unit rates. So well A is 275, so that's going to be faster. Okay, so let's reflect. Come on. Whoop. So describe the relationship among the slope of the graph of well A's rate and the equation representing the well A's rate and the constant of proportionality. So here's well A. Slope, unit rate, constant of proportionality. Think about all of those and I'll be right back. Okay, my dear. So we have the slope and the constant of proportionality equal the same value, 2 and 7/500, in the equation y equals 2 and 7/500 x. So slope and constant proportionality are the same thing. Okay, so I have this lovely additional example. See the equation, I'm reading right up here. The equation of y equals 1 and 2/10 x represents the rate in beats per second that Lee's heart beats. So we have Lee, y equals 1 and 2/10 x. So that'll be for Lee. The graph represents the rate that Nancy's heart beats. So this is Nancy's heart. Determine whose heart is beating at a faster rate. So with Nancy's heart, what I'm going to do is find the slope, because this is the slope, this is the unit rate. So I'm going to compare the slope. So I think I'm counting by 2 and 5/10 each time. And I have 5, 4, so I can use this point here. So rise is 5, run is 4, and this is for Nancy. So Nancy, she's going to be rise 5, run 4. And since we already have Lee as a decimal, we'll make this one into a decimal so it's easier to compare. So that'll be 1, 2500ths. So Nancy's going to be y equals 1 and 2500ths x. So Nancy's heart rate is 1 and 2500ths beats per second. And Lee's is 1 and 2/10 beats per second. So I would say that Nancy's heart is beating faster because her rate is higher. So Nancy's heart is beating faster. And the problems I love the most are the your turn problems. So read about the relationship, about the plane flying. You've got plane A, which is an equation. You've got plane B, which is a table. So you've got to find the slope and the rate of speed for plane B and determine who's flying at a faster rate. So take a couple minutes and come on back. Okay, so what we did here is we took the 375 for plane A. That's going to be the unit rate, the rate of speed, the constant of proportionality. Plane A is flying at 375 miles per hour. Then for plane B, you can take 850 minus 425. 2 take away 1. That's 425 over 1. So this slope, this rate of speed, this unit rate, this constant of proportionality is 425. Since this number is larger, plane B is flying faster. You'll have a problem similar to this on your test, which will be on Wednesday, Thursday, probably Thursday though at this point.